So the second part of this lesson is dividing rational expressions. So the last one was all about multiplying. Now we're going to divide. So before we think about rational expressions too much, let's just think of a rational number. So any fraction that we're dividing. Okay, so let's go 2 over 3 divided by 1 over 6. Okay, so when we're dividing these, the biggest difference between dividing and multiplying is that we do what I like to call the good old flip and switch. Okay, so what we have to do is our first term is going to stay the same, but our second term, our numerator and denominator, are going to switch spots. Okay, so our 6 goes on the top and our 1 goes on the bottom. And this is what we call the reciprocal. Okay, you can even think of it as the refliprical. Okay, it's kind of a way to remember. The other thing that changes is that, so we have the flip. The switch comes in that we're switching our operation. We're not going to divide anymore. We're actually going to multiply them. Okay, and once we've done this, this becomes a really easy problem for us to solve. It's just like the multiplying we did in the last lesson. So if we have 2 times 6, that's equal to 12. 3 times 1 is 3. And so we get a final answer of 4 after we reduce. So we can say 2 divided by 3, or 2 over 3 divided by 1 over 6 is equal to 4. Okay, so we follow the same sort of procedure when we're working with rational expressions. So even though we're not working with just numbers and we have x's and stuff in there, things work very similarly. Okay, so for our first example, let's do x minus 3 over x squared minus 9 divided by x over x plus 3. Okay, so just like when we're multiplying, our very first step is always to factor first. Okay, that's the most important thing for us to start with. So the first thing I'm going to do is I'm going to look at what I have here. X minus 3, can't factor that, right? But then I might look at something like, x squared minus 9. And I say, okay, well, x squared minus 9, that I can factor. That's a difference of perfect squares, right? So I'm going to turn this into x minus 3 and x plus 3. Okay? Then when I look at my other side, I say, okay, x plus 3 and x, those can't be factored, right? So first step is always to factor. Next thing we want to do is the flip and switch. Okay, so after that, flip and switch, we say, okay, well, our first term doesn't change at all, so it's still going to be in factored form, but nothing's changed, x minus 3. But after we've done the flip and switch, it's a multiply, and our numerator and denominator switch spots. Okay, so that's looking pretty good. Once we get to this point, things are working exactly like one of our multiplication questions, right? So I can say, okay, these cross out, these reduce, and if I look at this, I say, okay, my first term is now 1 over 1 multiplied by 1 over x. Okay, so for my final answer, I get 1 over x. Okay. The only thing that really changes besides the flip and switch is our non-permissibles. So normally we know, okay, we'd have to look here and here. Okay. The thing that becomes a problem is that this guy right here, okay, I'll put a big circle around him. This x becomes part of the denominator here, right? So our NPVs have to include anything that is ever in the denominator. So I'm going to have to look here, here, and here. Okay? Other than that, the same rules apply. I always want to look at the NPVs from before I simplified, right? So if I look at my NPVs, okay, I know that they have to include that x cannot equal positive or negative 3 as well as 0. Okay, so I'm going to have to look in 3 places now. So in some questions, I'm going to have lots of NPVs. Okay, so let's do some examples together. So if I look at, say, something like, let's do x minus 5 over 3x squared minus 9x. Okay, and we'll divide that by 5 over 6x minus 18. Okay, we know our first step is always, always, always to factor, right? No matter what, that's what we want to do first, no matter what type of question. Multiplying, dividing, adding, subtracting. Okay, so first things first. We can say, okay, x minus 5 can't be factored, but 3x squared minus 9x definitely can. Okay, so here we have a GCF of 3x, right? And that leaves us x minus 3 on the bottom and 5 on top. Okay, then in our other one, I know that, oh, sorry, it was x minus 5 on top. I know that 5 can't be factored, right? But 6x minus 18 should leave me with a GCF of 6 and x minus 3. Okay? And so I know that anytime I see a match like I have here, that things are looking pretty good. Okay, so from here we say, okay, we've done our factoring, let's do the flip and switch. So our first term doesn't ever change, right? So we have 3x, x minus 3, and then in the numerator I have x minus 5. But our denominator, we're going to flip it, so we get 6x minus 3 on top over 5, and we're changing it to multiplying, so that's where that switch comes in. So what happens now? As soon as we've done the flip and switch, it's just like a multiplying problem. Okay, we're going to multiply across the top and across the bottom. We have a couple options though. If we would like, we are always welcome to simplify things first a little bit. And I often recommend that because it can make our lives easier, right? I don't want to multiply x minus 3 if I don't have to, so I'm going to simplify those out. What I never want to see is I don't want to see you go and cross those 5s out, right? We can't do that because what we have up in the numerator is actually a binomial. Okay, there's like invisible brackets around it, so we can't just cross out those 5s there. Something I can cross out though is I can say, okay, well this 3, if I divide by 3, gets rid of it. And if I divide by 3 here, I get left with a 2. Okay, and if you're ever thinking, oh, this is getting kind of messy, from here we can stop simplifying and go straight into the multiplying. Okay, and then if we find at the end we are not done simplifying, we can do more at the end. Okay, so I have 2 multiplied by, actually let's just rewrite this so it's neater, right? So I have x minus 5 in the numerator, and in the denominator I have just x. And on the other side I have 2 over 5. Okay, now let's do our multiplying straight across. Okay, so I just want to be careful that I remember these are like invisible brackets, right? So for my final answer, I'm going to have 2 multiplied by x minus 5 over 5x. Okay, and then at the end I always want to do a double check to make sure, okay, is everything factored, everything is reduced, and it looks pretty good right now. Okay, the only thing I'm missing for full marks is I would want something about NPVs. Okay, and so we remember for NPVs I have to look in multiple different places. I look at both denominators and the second numerator because that becomes a denominator right here. So if I'm looking, I have 3x squared minus 9x, but where I actually want to be looking is I want to be looking when we're in factored form, right? That'll make my life way easier. So if I look at this, I say, okay, 3x, that means x cannot equal 0, x minus 3, x cannot equal positive 3. Okay, x minus 3, got that covered. And then for 5, there's no NPV because there's no x involved. Okay, so the biggest thing to really be careful of is always, always, always make sure that when we're working with these, you're factoring and you're simplifying as you go. I recommend you simplify after you do the flip, right? After this step, okay? Just because you don't want to start doing like crazy things with your simplifying before we get into the multiplication. Okay, so the only things that are different for dividing, just to recap, is we do the flip and switch, right? That refliprical, and we switch the operation. The other thing is those NPVs, right? So we know that I'm looking in both denominators and also the numerator. Okay, so our NPVs are going to be a little bit different as well. Okay, and that's all there really is to dividing rational expressions.